On December 28, 2025, two jet-powered unmanned aircraft took off into Turkish airspace and performed something no country had publicly demonstrated before. Flying at high subsonic speed, the two aircraft maintained close formation without any human input, relying entirely on onboard artificial intelligence, sensors, and real-time data exchange. The aircraft were Baykar's Kizilelma unmanned fighters, and the flight marked the first fully autonomous close formation mission conducted by combat-capable jet-powered drones. While the event itself was brief, its implications were significant. Formation flight has long been one of the most complex challenges in aviation, even for piloted aircraft. For unmanned systems, the difficulty increases dramatically, especially at higher speeds where reaction times are compressed and margins for error are small. By demonstrating that two armed fighter-class unmanned aircraft could fly in close proximity without pilot control, Baykar signaled that autonomous air combat is moving from experimentation toward practical reality. Kizilelma is not a continuation of earlier drone designs, but a departure from them. Unlike surveillance-focused or lightly armed unmanned systems, it was conceived from the beginning as a jet-powered combat aircraft capable of operating in contested airspace. The concept traces back to Turkey's MAIOS program, which began in the early 2010s as an effort to explore unmanned fighter-class platforms. That effort materialized publicly in 2022, when Kizilelma was unveiled and completed its first flight in December of that year. Since then, the program has advanced at a notably rapid pace. Over the course of 3 years, Kizilelma progressed from early prototype flights to high-speed testing, autonomous takeoff and landing, naval compatibility trials, weapons integration, and air-to-air engagement demonstrations. By early 2026, 5 prototypes had flown, with 2 aircraft already completed to serial production standards. Baykar has confirmed that the first operational deliveries to the Turkish armed forces will begin in the first quarter of 2026. In physical terms, Kizilelma occupies a space traditionally associated with manned fighters. Comparable in size to an F-16, it features a low observable airframe designed around internal weapon carriage, canard delta aerodynamics, and twin-canted vertical tails. Its maximum takeoff weight varies between roughly 6 and 8.5 tons, depending on configuration, and it is designed to carry up to 1.5 tons of payload. With a combat radius approaching 500 nautical miles and endurance of around 3 hours, the aircraft is intended for missions that go well beyond the reach of earlier Turkish drones. Performance has been a central focus of Kizilelma's development. Early test aircraft flew with lower thrust engines to validate flight control systems and aerodynamics. In January 2026, Baykar confirmed that Kizilelma had achieved a sustained cruise speed of Mach 0.8 during testing. This places the aircraft firmly in the high subsonic category, allowing it to operate in the same operational tempo as modern fighter jets, rather than lagging behind as a slower unmanned platform. This level of performance is essential to the roles Kizilelma is designed to fulfill. At high subsonic speed, the aircraft can escort manned fighters, reposition rapidly across large areas, and operate inside contested airspace without becoming a limiting factor for the formation. Combined with afterburner capability, the aircraft gains the ability to accelerate quickly, perform short-deck operations from vessels such as the Turkish Navy's TCG Anadolu, and execute evasive maneuvers that complicate interception by adversary aircraft or air defenses. During 2025, the aircraft conducted live firing tests with precision-guided munitions and validated its air-to-air combat capability using the Gök beyond visual range missile. These tests were supported by the integration of the Murad AESA radar, electro-optical targeting systems, and multi-sensor data fusion. In one demonstration, Kizilelma detected, tracked, and engaged an aerial target autonomously, confirming that it can perform missions traditionally reserved for piloted fighters. Internal weapon bays play a key role in reducing radar signature during such missions, supporting survivability in heavily defended environments. Underlying all of these capabilities is a high degree of autonomy. Kizilelma is designed to perform every phase of flight autonomously, from taxi and takeoff to mission execution and landing. While human operators remain involved, particularly during launch and recovery, a single operator is considered sufficient during the mission itself. Triple redundant onboard computers manage navigation, mission planning, sensor fusion, and flight safety, enabling the aircraft to adapt dynamically to changing conditions. The autonomous close formation flight, conducted in late 2025, demonstrated that Kizilelma can coordinate with other aircraft, maintain spatial awareness, and share tactical data in real time, laying the groundwork for future multi-aircraft operations. In a global context, Kizilelma occupies a space that many major powers are only now approaching. The United States continues development of its collaborative combat aircraft and Skyborg initiatives, while Australia's MQ-28 and America's XQ-58 focus on loyal wingman concepts optimized for high subsonic flight. China's comparable programs remain largely undisclosed. As of early 2026, none of these efforts have publicly demonstrated fully autonomous close formation flight between combat-capable unmanned fighter aircraft. In that sense, Kizilelma represents one of the most mature examples of a jet-powered unmanned fighter currently in testing. The delivery of Kizilelma to the Turkish Air Force in 2026 carries implications that extend beyond the platform itself. For the first time, Turkey will field an unmanned system capable of conducting air-to-air combat, beyond visual range engagements, and coordinated operations alongside manned fighters. This enables new approaches to air power, where unmanned aircraft can absorb risk, extend sensor coverage, and increase the density of weapons and platforms in the air without exposing pilots to the same level of danger. More broadly, Kizilelma reflects a shift in how air forces are thinking about the future of combat aviation. Rather than replacing manned fighters, platforms like Kizilelma are designed to complement them, acting as force multipliers within a networked battle space. As autonomous systems continue to mature, the distinction between piloted and unpiloted aircraft will become less about capability and more about how risk, cost, and flexibility are managed. By the time Kizilelma enters service, autonomous air combat will no longer be a theoretical concept or a distant goal. It will be an operational reality, shaped by real flight testing, real weapons integration, and real doctrine. In that context, Kizilelma is best understood not as a dramatic leap into the unknown, but as a deliberate and methodical step toward a future where unmanned fighters play a central role in modern air warfare.